In this video, we're going to find derivatives implicitly for exponential functions. Let's go ahead and look at number 27, and you'll see that there's an e to the y in this problem that makes it an implicit differentiation problem. And so for our first piece here, we need to take the derivative of the first part, leaving the second part alone, plus the derivative of the second part, leaving the first part alone. So that's going to be an x times e to the y times the derivative of the exponent y with respect to x is dy dx. We're told to write it as dy dx, not y prime. So that's what I'm doing. Derivative of negative 10x with respect to x is negative 10. And the derivative of 3y with respect to x is 3 dy dx. Keeping my dy dx terms on the left-hand side, get x e to the y plus 3 dy dx, moving the other items to the other side by subtractions. So we're going to add 10 to both sides to get rid of that negative 10. And we're going to subtract e to the y from both sides to get rid of a positive e to the y. Now we're going to divide both sides by x e to the y plus 3, x e to the y plus 3, dy dx is 10 minus e to the y over x e to the y plus 3. All right, let's go ahead and look at number 29. 29 is x squared e to the negative x plus 2y squared minus xy is equal to 0. Derivative of the first part, leaving the second part alone, plus derivative of the second part, leaving the first part alone, plus the derivative of 2y squared is 4y times dy dx, and then derivative of the first part, leaving the second part alone, plus derivative of the second part, leaving the first part alone. All that equals to 0. So we have our dy dx terms are 4y and negative x dy dx. Everything else goes to the other side. This will be a positive x squared e to the negative x. This will be a positive y. This will be a negative 2x e to the negative x. When they go across the equal sign, they change sign. Divide by 4y minus x, 4y minus x, dy dx is equal to x squared e to the negative x plus y minus 2x e to the negative x over 4y minus x. And book has it written as this, which is just fine with me. They just factored that e to the negative x out that was common in these two exponential terms. Let's go ahead and stop there. And we'll come back next time and talk about finding the second derivative of an exponential function. And just that'll be enough to talk about finding higher order derivatives of exponential functions too. So we'll come back and talk about that next time. See you for the next video.